Okay student, in this video I will discuss the sum related to the EMF, that means electromotive force, terminal voltage, internal resistance of a cell and the resistor in series and parallel combination. Okay, here I have written one sum, first sum here. In this circuit we have to calculate the resistance between AD, that means point this and this, and resistance between point AC, that means between this and this point. Okay, so here first I am telling you, whenever you are doing the solution of this type of the network circuit, always stretch the point, stretch the network so that it will look like flat, that means horizontal. What I am doing here, just watch. Just I am stretched the point A and D arms, across arms, and it will look like this. Okay, this is point A and this is point D, and in between these points is B and C. All these resistance are of 2 ohms value. Okay, here the resistance in this arm are in series. Okay, and this total arms is in parallel with this resistance. Okay, so what will be the resistance? We can write it like this. First I will find the resistance to the upper arm, that means we can say RS for upper limbs equal to 2 plus 2 plus 2, that means equivalent resistance for this arm is 6 ohms. Okay, now the RAD is the parallel resistance, that means total resistance between these two terminals. We can write like this: 1 by RAD, okay, equal to 1 by 6 plus 1 by 2. Okay, and this can do like this: 1 plus 3, that is equal to 4 by 6, that is equal to 2 by 3. That means 1 by RAD equal to 2 by 3. Okay, therefore RAD, I just inverting the numerator and denominator here, it will be 3 by 2, that is equal to 1.5 ohms. Okay, so the resistance between A and D is 1.5 ohm. This is not necessary for you to write. You can write the resistance between A and D, upper arm of A and D. Okay, now this is the first case, and now I am going to discuss the second case. Okay, the resistance between A and C point. So again, what I am doing here, I will stretch these 2 points to make it look like this, right, horizontal. So it will become like this. I am just again drawing the circuit. It will be like this. Okay, and this point A and this point C, right, and this point is B and this point is D. Okay, so RAC we need to calculate, equal to, in one line we can say that this is 4, this is 4. Okay, in short we know that RP for the 2 resistor can be directly calculated by this formula. Okay, it's very short. So we can say 4 into 4 by 4 plus 4, that is 16 by 8, that is 8 to just 16, 2 ohms. Very simple. How this is derived, I want to show you here. RP 1 by R1 plus 1 by R2, right? the LCM is R1 and R2. Here becomes R2 plus R1. Therefore I am inverting this one, Rp by 1, so this become R1 R2 by R1 plus R2, and this is nothing but what I have written first, R1 R2 by R1 plus R2. Okay, I think you can keep this equation in your mind so that you can directly and quickly calculate the parallel resistance between 2 points. Okay, so now I am going to discuss the second sum of this. This is the second sum. Two resistors of resistance 4 ohms and 6 ohm are connected in parallel, and the combination is connected across a 6 volt battery of negligible internal resistance, right? So we have to calculate total resistance of the circuit, that means equivalent resistance, and current through the battery and current through each resistor. Okay, so first of all I will draw the circuit diagram, right? So these two resistors are connected in parallel, that means first I am drawing the two resistors, those are in parallel. Okay, just I will draw step by step. Okay, this is 4 ohms resistor and this is 6 ohms resistor. These two resistors are in parallel, and the combination, that means this combination, okay, is connected across 6 volt supply. That means across means this is the across, this is the across, that means 2 in is connected like this. 6 volt battery, this bigger one is plus terminal and smaller is minus terminal. This is the usual convention, right? So we have to calculate the equivalent resistance of this two one. Okay, after that we have to calculate the current I. This current I is flowing through the battery, that's mean here, here, here. Okay, in this conductor and through the battery current I is flowing, right? But here this current get divided into two parts. Okay, I can say it I4 and I6, right? So this is the branch current across through the resistor 4 ohms and through resistance 6 ohms, right? So let me first calculate the equivalent resistance of the circuit. So first one, 1 by Rp equal to 1 by 4 1 by 6. Oh, this is the, and directly we can find this as Rp equal to, you know this, I discussed about this, so it becomes 24 by 10, that is 2.4 ohms. Okay, now we know the resistance, total resistance, and we know the voltage. So current, that means I, main current, equal to V by R. Okay, this is the second parameter, that is equal to 6 by 2.4, right, ampere. This becomes, like, replace the decimal, so 12 2 ja 12 5 ja, that means equal to 2.5 ampere, right, or 5 by 2 ampere. So 2.5 ampere is the main current here. Now I can calculate the current I4 in the, we can find in two ways, right? So one simple way is the voltage, that means I4 equal to V by 4 ohms, right, or resistance, that means R4. We can say this is R4, just for the clarity of, this is R4, right? So it become 6 by 4, because this 6 voltage is also apply across this and this. So in parallel circuit the voltage remains same across all the parallel circuit, right, parallel arm. So it becomes 3 by 2 ampere or 1.5 ampere. Okay, this can also be calculated through the resistor division method, that means through the current division method. So I4 can be written like this: main current into 6 by 4 plus 6. Okay, resistance of this divided by total sum. This is the current across this, right? This become 2.5 into 6 by 10. That means it becomes 6 5 ja 30, 15 by 6 5 ja 30. Okay, 15 by 10. That means 1.5 ampere, right? So this value and this value is same. What I applied here? We applied here a formula. This one, I4 equal to main current into R6 by R4 plus R6, right? So this is, by this formula we can calculate the branch current in parallel combination. Okay, and similarly we can write I6 equal to total current into R4 divided by R4 plus here is R6. Okay, and if we know any of this current and this main current, so we can also calculate like this, because I equal to I4 plus I6 for parallel combination, right? The currents of the each arms is added to give the main current, right? So if this is 2.5 ampere and this is 1.5 ampere, therefore I6 can be calculated like this: I minus I4, that is 2.5 minus 1.5, that is equal to 1.0 ampere. Okay, so I think you understand this sum clearly, and I calculated the current through 6 ohms resistor in this way, but you can also do that in this way also. I6 equal to V by R6, that is equal to 6 by 6, that is equal to 1 ampere. Okay, so whatever, just I have calculated this sum through this way only because you know finding or calculating the electrical parameter in all multiple direction, right? So clear understanding is most important, right? So this is simple sum, but when you will deal with the critical sums, it will be very helpful for you. Okay, this one is the third sum. Okay, 3 resistors of resistance 6 ohms, 4 ohms and 2 ohms are connected to an ammeter and battery as shown here in the diagram, right? This is the ammeter and A is the sign of the ammeter with a circle. Okay, so we have to find the resistance of the circuit. Okay, total resistance of the circuit or effective resistance of the circuit, it has been written 2 times. I am deleting one here. Okay, okay, it cannot be deleted. I am just blacking it out. Okay, this one, right? So we have to calculate the effective resistance, or we can say equivalent resistance of the circuit and reading of the ammeter, right? So what will I do? First, I have already explained you that whenever you want to find the equivalent resistance of the circuit or any electrical parameter, then stretch the circuit, right? So I will stretch the circuit from here and here. okay, because we are interested to find the current through the emitter A. Okay, so we can redraw the above circuit diagram like this. Watch it. Okay, this one is the just this is the ammeter, and this one is the 6-volt battery, and this is connected like this. Okay, right. I think now it is more clear and more easy to understand the sum, right? So what will I do? I find the series resistance of this one, and we calculate the parallel resistance of 6 ohms and this value, okay, to find the effective resistance of the circuit. So the effective resistance of the circuit is this one become 6 ohms and this one also become 6 ohms, and this become in parallel. So RP equal to can be easily write like this. I think it is very clear. 36 by 12 equal to 3 ohms. Sorry, 3 ohms, right? So the effective resistance of the circuit become 3 ohms. The circuit become this. Now it is very simple to calculate the current across this volt across this circuit, and ammeter reading means we have to find the current across this circuit. So current I equal to voltage by resistance, that is equal to 6 by 3, 3 2 just 6, that is 2 ampere. So the reading of the ammeter equal to 2 ampere. So this is the solution. And here one thing I want to clear you, if the diagram of a battery is given like this, that means you always understand that there is no any internal resistance of the battery, right? If a battery have internal resistance, the drawing will be like this. If this is a battery and we draw like this, this is the complete symbol of a battery. This is 6 volt and this is RP. We can take RP equal to 2 ohms. This is the internal resistance of a battery, right? It is because the lead acid battery have plates, right? And we know the theory of the electrolysis. So the flow of the current across this plate and through electrolyte and again returning through the cathode suffers a resistance to the flow of electrons. So that resistance is the internal resistance of the battery, and we say it RP, right? So this is the practical case, but ideal case always when we are doing the sum, this one is the ideal case, that is 6 volt, no any battery or without any internal resistance, okay, right? So this is the third sums, and the next sum I will do the battery which have internal resistance, okay. In this fourth sum I will calculate the resistance of the circuit, okay, and the heat loss inside the resistance. That means this resistance is the internal resistance of the battery, right? So 3 resistors of resistance 4 ohms, 2 ohms and 2 ohms are connected to an ammeter and the 6 volt battery. Here is not an ammeter, I am showing here this one is the ammeter. Okay, 6 volt battery, and we have to find the total resistance and the heat loss inside the internal resistance of a battery, right? So here heat loss inside the battery, that means the heat loss due to the internal resistance of the battery is actually, right? So what will be the sum here? So usually what will I do? We will stretch the circuit as usually I told you, like this. This is 6 volt battery, this is the internal resistance of the battery, and these are the combination of the resistor. Okay, I think it is clear. Now the first case is the equivalent resistance, that means this one will be Rp equal to 4 into 4 by 4 plus 4, that is 16 by 8, that is equal to 2 ohms, right? So the current across the circuit can be easily calculated because we found the resistance, right? So the current will be voltage by resistance, that is 6 by 2 plus 1. Now here the resistance is incomplete. Why I am saying? Because we have not taken the internal resistance here. Okay, so the total resistance, total effective resistance will be Rp plus 1 ohms, that means 2 plus 1, that is 3 ohms. Okay, that's why I am here done the 3 ohms, right? This is the internal resistance of the battery, so it becomes 6 by 3, that is 2 ampere, right? Therefore heat loss inside the battery will be I square Rp, where Rp is the internal resistance of the battery, 1 ohms. Therefore I square Rp is the quantity of heat loss inside the battery, so it becomes 2 square into 1, that is 4 into 1, that is 4, it is watt. Okay, you know this because in the previous video I have already discussed about the power of a electrical appliance, right? So 4 watt heat is lost inside the battery, right? We can easily convert this 4 watt into calorie, you know this. Okay, so these were all about the some discussion of the electrical circuit, and if you have any sum which you want to solve and you are unable to solve that, so please comment below this video. Okay, I will try to solve those sum, right?